Welcome again. Today we are talking about the projectile motion. So if you have ever thrown an object and you wondered how far it will go or how high it will reach. So this is all about the projectile motion. It's all about object being thrown at an angle. So today I'm going to show you how to solve projectile motion step by step in a way you actually understand. So before we go further, let's describe what projectile motion is. So projectile motion is motion of an object thrown at an angle under gravity. It follows a curved path called a parabola. So when you're talking about projectile motion, it's something like this, an object moving like this. We can see this shape is what we call a parabola. Now again, projectile motion can be summarized, or everything can be done on this same diagram. So what's there is, on this diagram, there is what we call the initial speed or initial velocity. So initial velocity is here. It's moving like this. So this initial velocity, as you can see, projectile motion is all about objects moving in 2 dimensions. So projectile motion is under motion in 2 dimensions. The reason is, as you can see, this object is not moving in one direction. For example, it's not moving in horizontal direction or vertical direction only, but it is moving in both the x direction, which is horizontal direction, and the vertical direction. So because of this, we have the x component and the y component of velocity. So whenever you are given things relating to projectile motion, there is vertical component and the x component, which is horizontal component. Now what you should know, as this object is moving, when it comes here, the vertical component will be reducing, but the horizontal component is just, we won't change. Then we have the initial speed, which is there. Since you guys, I'm sure by now, for you to come to this topic, you have done vectors. It means you can know how to find what the initial speed given the horizontal component and the vertical component, or you can find the vertical component and the horizontal component given what the initial speed. But you are going to do this also. So as the object is moving, it will reach a maximum height here. When it reaches this maximum height, there will be no vertical component, because vertical component was reducing, and when it reaches the maximum height, there's going to be horizontal component only. So like this, at the end, the object will start moving down. When it comes to this point, the object will start moving what? Down. But what you should know is the horizontal speed is just constant, it doesn't change. Then we have the initial speed. It will reach this point now where the vertical component has gone down, has increased. So it's increasing, but increasing what? Downward. Now the key points you should know here is, gravity only affects vertical motion, and horizontal motion stays constant. The vertical and horizontal component motions are independent. Now, having talked of this, now let's break this V, which is this one. Let's break this initial speed into components. So when you're talking about speed of an object moving like a projectile, like this one, which is moving in 2 dimensions, there are 2 components. We call them the x component and the y components. And this horizontal direction is what we call x component, and that one is y component. So even this one is going to be called v not y, which is initial speed in the y direction. This one is going to be called v not x, which is initial speed in the x direction. Now what's the horizontal component? The horizontal component, we find it because there is an angle here. So we say v not x is equal to the v initial cos theta. So this is how you find it. There is no other formula for finding the initial speed in the x component. So whenever you have the angle and the initial speed, you can find the velocity in the x component in the horizontal direction. Also for y, you just say v not y is equal to what? V initial sine theta. But remember, this angle, don't make a mistake. Don't make a mistake. For example, it's like this angle. They put the angle like that one. They put it there instead of this one. They remove an angle here. So, should know here is when you are going to say the initial, I'm sure you learned this in vectors. V naught x is going to be V initial. For this one, since the angle is not touching the x component, which is the horizontal direction, we are going to say sine theta instead of cos theta. So we put cos theta if the angle was here. So V naught y is the one which is going to have what? The cos. So know this. You use the V initial cos theta if the angle was touching was from the what? From the x-axis going to the initial speed. So that's all about the two components. So imagine you had we had 80 meter per second and the angle was 30. So for us to find the V naught x, we just say 80 sine 30 for the x component. For the y component, we say 80 cos 30. Remember, it's because the angle has been, or if you want to use the cos, unless we say 90 minus 60, here minus 30 is 60. So that's when you can use now the V naught x is equal to what? V cos 60. Now let's talk about key formulas in projectile motion. So these are the formulas I'm going to give you. You are going to be using in projectile motion whenever you are asked any question. And how we derive these formulas, I'm going to explain them in the next video. But for now, just understand the formulas. So the first formula is the time of flight. For example, an object has moved from that point to that point. Now they tell, can you calculate the time the object will take to move from here to there? So what do you need for you to calculate that? The only thing you need is, so the formula is 2 times initial sine theta over g. So this is what you need. So for example, the angle was 40 degrees and the initial speed was maybe 25 meters per second. So our time, let's punch our calculators. Our time will be, we start first 25 sine 40. The answer is 16 times 2 divided by 9.81. The answer is 3.28. So the answer is 3.28 seconds. Now, what you should know is this point, we call it the maximum height. Now, how do you calculate the time it takes from here to the maximum height? We just say the same formula, which is time of flight over 2. So for this one, the answer you find, you just divide by 2. Because from here to the maximum height is equal to the maximum height again to the ground. So you can be asked, can you calculate the time from the what? The object takes from rest to what? To the maximum height. So you just use the same formula of time of flight, just say over 2. Now what about maximum height? Maximum height, we calculate maximum height, you only need the initial speed sine squared theta over 2g. So for you to calculate the maximum height the object will take, how far the object going to go in terms of the vertical distance, the maximum height, you just need the initial speed and the angle. The gravity, we know that is negative 9.81. So that's the formula for calculating the maximum height. Another thing also is the range. So for the range, it's like for this one, it's in the horizontal direction. How far can it go in the horizontal direction? So that's the answer we are answering, the question we are answering. So for this one, it's similar to that one, but it's u squared, the initial speed squared. For this one, it's sine 2 theta instead of sine squared theta over g, and it's not over 2g, it's over g. So let's hope you are writing these equations. So this is the formula we use for the range, which is u squared sine 2 theta over what? Over g. So these are the formulas you need to take. So most of the time you need application. For example, they won't give you the initial speed. You need to find it using maybe the vertical and the horizontal component. So always draw a diagram first. It's the one which usually makes everything what easier. So whenever you are and they give marks for drawing a diagram. So another thing, a exam tip which is there is maximum range occurs at 45 degrees. Maximum range occurs at 45 degrees. And also time to maximum height is equal to time of flight over 2. Another one is complementary angles give the same range. So for complementary, for example, when we are talking about angles like 90 degrees maybe and the 30 are giving the same range. I will explain it also in the next video of giving the same range. So the maximum range occurs at 45 degrees. So this one, what they are trying to say in terms of angles is like this. When you project an object at 30 degrees, it will just go like that one. It will come here. But when we project it at 45 degrees, it will try to go up, then it comes like this. That's 45 degrees. But when you project it at somewhere maybe 60 degrees or 90 degrees, it will go high, or 75, it will go high, then it will come again, it will come, so it's lower. So the maximum height occurs at what? Maximum range occurs at 45 degrees. You may find there are others like 60 degrees. So that's just what they are saying when they are saying complementary angles. So you need to know which angle, for example, which one goes with 90, which one goes with 60 degrees. But what you should know is 45 degrees gives the what? The maximum range. So let's look at an example. We are given a simple example, which is a ball is thrown with a speed of 20 meters per second at an angle of 30 degrees to the horizontal. Find the time of flight, maximum height, and the horizontal range. So for the time of flight, we know that the time of flight, the formula of time of flight is 2u, which is initial speed, sine theta over what? Over g. What's the initial speed? We have been given the initial speed to be 20, or 2 times 20 sine, what's the angle? 30 over what's the gravity, which is just what? 9.8. We just punch that one, and the answer we are going to find is what? 2.04 seconds. So that's our time of flight. So we just placed in the formula, and we got the answer. Now what about the maximum height? So again, the formula of maximum height, I said maximum height is equal to u squared sine squared theta over 2g. So for us to find the value of the maximum height, we know the initial speed is 20, so it's just 20 squared times sine squared theta, which is just a. So for this one, to solve it properly, we know that initial speed sine theta, it's the initial speed in the what? In the y component. So what we are going to do is this. We are going to rewrite this formula in this form: v not y, which is just squared. So that's just what it means for us to make this formula easy. That's what we are going to do, over 2g. Now we need to find a v not y, which is the vertical component of speed. So it's just 20 sine 30. When we say 20 sine 30, the answer we are finding is what? Is 10. So we are just going to say 10 meters per second squared. 10 meters per second, we square it over 2 times 9.8. And the answer we are going to find is 5.10 meter. which means this object, the range of this object in the vertical, the height this object will go is 5.1 meters in the vertical direction. So that's the maximum height. Now, what about the range? How do we find the range? For the range, since they said the horizontal range, we are going to use this formula. For the horizontal range, we want the distance it's going to move in the what? In the horizontal direction. So we are just going to multiply. So this is the formula we use for the range, for example, in terms of horizontal range. So we just get the x component of the speed times the time of flight. Since we in this formula, in this question, we had the question of time of flight. So we know that the initial speed in the x component is just 20 cos 30, which is 17.32. 0.32 times what's the time of flight? The time of flight that we find at first, it was 2.04. So when we multiply these two, the answer we are going to get is 35.3 meters. So this is the formula when you're finding the horizontal range. We want to find the distance it's going to cover in the horizontal direction. So you use this formula, which is the initial component of speed times the time of flight. So it's going to move what? 35.3 meters. So that's all about this question, and that's all about projectile motion. Let's do another example on projectile motion. So we have another example. Imagine you are throwing a basketball to score. The ball leaves your hands at 15 meters per second at 40 degrees. How far will it go? So when we look at this question, it's like simple, but they are looking for the range, just as we calculated earlier. And we said the range is equal to this formula, which is the initial speed in the x direction. Now, what's the x? The ux. The ux, we know that the ux is equal to what? 15 cos 40. The answer is what? The answer is 11.49. But how far will it go? What about the time of flight? So we need to calculate the what? The time of flight. And we know that the time of flight is 2 v naught y over g. V naught y is the initial speed in the y direction, which is initial speed sine y. So I've just summarized it. So we need to find this one again. So let's go ahead and calculate the time of flight. So the time of flight, when we punch on our calculators, we are going to say 15 sine, which is 40, which is 9 point times 2 divided by 9.81. The answer is 1.96. So that's our time of flight. Since we found that our time of flight, we just multiply them, which is the initial component of speed in the x direction is 11.49 meter per second times 1.97. It should be 1.97 seconds. The answer we are going to get is just 11.49, so which is 22.6 meters. So this is the range. This is how far the ball is going to go. So you see, projectile motion is all about just application of what you know. So try solving some problems on projectile motion. So that's all about the projectile motion. Next time we are going to talk about how these formulas were derived, the first formulas, how they were derived. Yeah. So if you found this video helpful, like and share, and also subscribe so your friends won't struggle with the projectile motion, so that they can also be able to see the video. And also comment in the comment section below. Physics is everywhere. So this physics is everywhere. Like from basketball to fireworks, projectile motion is the secret behind it all. So projectile is all about throwing things, any object which is projected like a projectile is projectile motion. So the next lesson, as I have said, don't miss it, unless maybe if you don't know how to know these equations we're coming about. So thank you for watching and see you in the next video.